Alright, this is your 7.5 homework, division properties of exponents. So remember, first thing you want to do is to write down the assignment. So we had page 443 to 444, 12 through 20. 12 through 20, can't write today, and 33 through 42. So notice neither one of these says odd. So we want to treat these, we're going to do all the problems. So let me get my book to the correct page and we can get started. So number 12 is going to be 3 to the 8th over 3 to the 6th. And when I'm doing division problems, I want to use 2 lines on my notebook paper just so things don't get so squished. So this is division of exponents, so we're going to keep the base, and the rule is that you subtract the exponents. So our final answer is 3 squared, and since we can do that in our heads, 3 times 3, I'm going to go ahead and do that and just get 9. In number 13, we're going to see what happens when we put 3 to the 6th on the top and 3 to the 8th on the bottom. We have 3 to the 6 minus 8, which is 3 to the negative 2. And since we do not want to leave a negative in our final answer, I'm going to go ahead and move it to the bottom. And then again, since I could do 3 squared in my head, so you see how this happens. When you have a larger number on top, you end up with a positive and an answer that's greater than 1. And when you end up with when you have a larger exponent on the bottom, when you subtract, you end up with a negative exponent, which gives you a fraction. So we'll just keep that in mind as we're working the rest of the problems and kind of try to predict. So here I've got d to the 14th over d to the 17th. So since the larger one is on bottom, I think I'm going to end up with a negative exponent, or just some variables on the bottom. So let me adjust my screen here. Number 15, I've got n to the negative 1 over n to the negative 4. So I'm going to write this out. I'm going to write my base, and then I've got my top exponent minus my bottom exponent. So negative 1 minus 4. Let me get out a different color marker here. So whenever I have subtraction, I add the opposite. So negative 1 plus 4 is negative 1 plus 4 is positive 3. So that's our final answer. Number 16, I've got 5s to the negative 7th over 10s to the negative 9th. So with division problems, like with any exponent problems, when you have constant terms in there or plain old numbers, you're going to follow the rules. If there's no exponents with them, you really don't have any exponent rules that you need to worry about. So I have got 5 over 10, and I am going to reduce that like a fraction. So we say 5 goes into 5 1 time, 5 goes into 10 2 times. So it's like I'm doing divide by 5 on top and bottom. So I've got my numbers dealt with. Now I need to deal with my exponents. So I've got s, and I'm just going to write it in the numerator for now because that's how my division rule works. So I'm going to put negative 7 minus 9. And so for my final answer, I'm going to get, let's see, negative 7 plus positive 9 is positive 2. So I end up with a positive 2 for my exponent of s. In number 17, we've got x to the 11th over y cubed all over x to the 11th y. So if you can see that x to the 11th over x to the 11th, they're just the same. Anything divided by itself equals 1. you could just cancel that. But if you don't happen to notice that, you can follow the rule and write it out as the base with a subtraction sign. And then here are my y's. So I'm going to be doing 3 minus 1. So when my exponent doesn't have, when my variable doesn't have an exponent, we can assume that it's to the first power. So I get x to the 0, y squared, and since anything to the 0 power is equal to 1, I can cancel that out that way. In number 18, c cubed d to the negative 5th over c to the 4th d to the negative 1st. So you have a couple of options. You could simplify this first with your negative numbers, or we could just follow the rule of division and go ahead and subtract them out. So I'm going to do that. I'm going to write down my variable c, and I'm going to show how I'm going to subtract my exponents. I'm going to write down my variable d, and I'm going to show how I subtract my exponents. And I'm going to work out the math, c to the negative 1, d to the negative 6th, and then I'm going to simplify using the negative properties. So since c is to the negative 1, c to the 1 can move down to the bottom, d to the negative 6, d to the 6th. Once I move it, I can lose the negative sign. And so there's no more variables left for the numerator. So I'm just going to fill that in with a 1. In number 19, and I'm going to drop down one line. Oops, I turned my camera. I'm going to just drop down one line just so it's not all crowded up in there. So I've got 10m to the 6th, n to the 3rd, over 5m squared, n to the 7th. So once again, my 10 and my 5 don't have any exponents, so I'm going to divide those just like a regular, just like plain old numbers. So I can either do 10 divided by 5, which is 2, or I can look at that as a fraction and say, oh, well, 5 goes into both. So divide by 5, divide by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. So I can write that, especially in my first step. That's not part of my final answer. So now I've got my m's, and I'm going to write it on the top, 6 minus 2. And then for my n's, I'm going to write it on the top for now. It's 3 minus 7. So we write it in the numerator when we're applying the rule. And then I can see here I'm going to get a positive 4 for my m exponent, but I'm getting a negative 4 for my n exponent. So this isn't going to be the final answer. Let me just go back down here, and I need to create a denominator to put those negative exponents into, m to the 4th, and then once I move that negative 4 to the bottom, I've taken care of the negative, so I do not bring it down with me. Alright, the last one for this section is number 20, m cubed n squared over m to the negative 1 n cubed. So I'm going to write down my variables, m, 3 minus 1, n, 2 minus 3. And now let me work out the math. So 3 minus 1, that is 4, m to the 4th. N to the 2 minus 3 is going to be negative 1. Fix my camera. And so I still don't want to have a negative in my final answer, so let me go one more step. I'll go m to the 4th, and then I need to create a denominator to put that in. So that's n to the 1. So let me take a moment and go back and put a box around all my answers and make sure they're all the way simplified. So this one in number 16, you might just see the answer as s squared over 2. We don't have to write 1. Okay, you can't see that at all. So here I am in number 16. I said we don't have to have that 1 there. You would see the answer to check it as s squared over 2. And okay, so now I'm going to go and work on 33 through 42. So 33, and turn the page and let's write some things down. Make myself a note, 33 through 42. So number 33, we have 3/8 squared. So we're going to think of that as 3 squared and 8 squared. So we get 9/64. Number 34, I've got 1 over a cubed. So that's 1 cubed over a cubed, which is 1 over a cubed. Number 35, I've got 3x over y, all of that quantity to the 4th. So now we have to be careful. We have to make sure and apply that 4th power to every single thing inside those parentheses. So I'm going to have 3 to the 4th, x to the 4th, and y to the 4th. And then I'm going to work out some of the math. So I know in my head that 3 to the 4th is 81. If you have to use a calculator for that, that's okay. But it's 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. And so there's no other variables that can be reduced. So I'm done. In number 36, I've got 2x to the 5th. No, 2x over 3y, all of that quantity to the 5th. So there are 1, 2, 3, 4 things inside of those parentheses that are going to be to the 5th power. 2 to the 5th, x to the 5th over 3 to the 5th, y to the 5th. And then you're going to go and work all of that out. So 2 to the 5th is 32, x to the 5th. 3 to the 5th is, so I could use my calculator, or I can just do 3 times 81, which was 3 to the 4th. So 3 to the 5th is 243 over y, times y to the 5th. 37, you're going to want to, you can do that one of 2 ways. It's 6 over 5 squared, all to the 3rd power. So you've got a couple of options here. And I'm going to work this one out both ways, so you can choose which way is better for you. Sorry, I got to adjust the camera. So the first way would be just to continue distributing. The only thing is 5 to the 2nd to the 3rd, that's power to a power. So you would just have to show that you're going to multiply that. So that's 6 cubed over 5 to the 6th. You have to be careful. 2 times 3 is 6. And then we want to use our calculators to work that out. So, or this could be an answer, like if it was a multiple choice test, that might be one of the answers. So, but if your answers don't have exponents in them, then you'll know that you've got to go back in and plug it in. So 5 to the 6th, 15,625. 216 over 15,625. Number 38. Here we have 2 squared, 2 to the 3rd, to the 5th. So you have 2 options for this one. Oh darn it, and I did not show you the other option for that one on number 37. Let me just write it out right to the side. So the other option would be to go 6 cubed over 25, because that's what 5 squared is. 5 squared is 25, and then 25 to the 3rd power is distributing that 3 to everything. So then you would still end up with the exact same answer. You would put 25 cubed into your calculator. So let me prove that. 25 to the third power, 15,625. So you still get the same answer. And so you kind of have those same options here with number 38. So we can work out the numbers, then take them to the power. We could use exponent rules to divide and take that to the 5th power. Or you could do 2 squared to the 5th and 2 to the 3rd to the 5th. So why don't we do it that way? So 2 to the 2 times 5 over 2 to the 3 times 5 equals 2 to the 10th over 2 to the 15th. And let's use our division rule, which is write the base, subtract the exponents. So that gives us 2 to the negative 5th, or 1 over 2 to the 5th. And if we wanted to go one step further, we know that 2 to the 5th is 32, so that's probably our best answer. In number 39, let's see, I've got 8 over n to the 5th, all of that quantity raised to the 6th. So in my very first step, I am going to just distribute that 6th power. 8 to the 6th over n to the 30th, so that's 5 times 6. And then I probably would invite you to leave it that way, but just to show you that we can, I can put 8 to the 6th in my calculator, and then into the 30th. So that's a good answer as well. In number 40, let's see what we've got. 2p over 9 raised to the 3rd power. So I don't have any exponents inside of there, so I'm just going to go ahead and distribute that. 2 is to the 3rd, p is to the 3rd, 9 is to the 3rd. So 2 cubed is 8, p to the 3rd, and then 9 to the 3rd is going to tell me what goes in my denominator. So I used my calculator and got 729. In number 41, I've got 2/5 to the negative 1. And so sometimes students might panic when they see that and not know what to do. So I'm just going to follow the same process I have for all the others and distribute my exponent. Whoop, that's a 5. 2 to the negative 1 over 5 to the negative 1. And then I'm going to use my exponent properties to know that if something's in the denominator, it goes up to the numerator. If something's in the numerator, it goes down to the denominator. So that's it. And last one, number 42, is probably pretty similar. I've got 5/4 all to the negative 4th power. So I'm going to first distribute my power. Then I'm going to deal with the negative exponents, moving 4 to the negative 4th. I'm going to move it to the top, and once I move it to its reciprocal location, I am going to drop the negative sign, and then 5 to the negative 4th, once I move it, it's going to lose its negative sign. So 4 to the 4th is 256 over 5 to the 4th is 625. So that is my final answer for that one, and that was number 42. So you are finished.